Now we've talked about confidence intervals and point estimates. When we were talking about confidence intervals, we were talking about taking a set of sample data and, given that set of sample data, providing a range of values that would cover the value of the parameter. That is, the parameter value, the actual value, would fall within this range with a certain confidence level. Now, when we were looking at single point estimates, with these, we were taking the sample data that we collected, and using that data, we were providing a single value estimate of what a parameter value would be. Now, there's times that we want to use each of these. We need to be able to give a little bit more information about the point estimate, though. We need to be able to talk about the standard error. So point estimates are not always going to be 100% accurate, as you might be able to guess. So we need to be able to say, well, what's the error involved here? Like, if we're off, are we off by a little bit or are we off by a lot? So to find the standard error, what we do is we take the square root of the variance. Now you might remember that we find the variance by taking the variance of the population and dividing by the sample size. So to find the standard error, we take the square root of the variance and find the standard deviation, or standard error. And so taking that, we end up with taking the standard deviation, or standard error, of the population and dividing by the square root of the sample size. So the larger our sample size, the smaller our standard error will be. And the smaller the sample size, the larger the standard error will be. And this makes sense because as the population, or as the sample size grows, it approaches the size of the population. And so the likelihood that we're off from the population parameter with our point estimate decreases. So that's really all we have to say about standard error with a point estimate.